Welcome to a video on how to find angles given ratios and finding angles in radian measure. I'm going to have examples here of how to find quadrantal angles, special triangle angles, and angles that are neither special or quadrantal. So begin by looking at the question and identifying whether the ratio that's provided for you, whether it's special or not. I like to remember that root 2 and 2 has to be where the radius is. And if that's not the case, then it's probably not a special ratio. So this right here, we have root 2 over 2. Now we never have both root 2 and 2 in a special triangle. If it's a root 2, it's a 1, 1 root 2. So this is written in a rationalized form, which I will rewrite in the other form. And so this is definition for cosine is x over r. And so you should recognize that these numbers are on a 45-degree angle. So the 45-degree angle is the related acute, or pi over 4. So automatically you know that your theta 1 angle and theta 2 angle will have a denominator of 4, pi something over 4, okay? So in order to find out that numerator, or how many sections of pi we're going to rotate to get that angle, we should draw a picture. You could use cast rule, or you could think of this as all students take calculus, so that it starts in quadrant 1. And cosine is negative in quadrant number 2 and quadrant number 3. Another way of thinking about it is that this x here is negative x. Radius is never negative. So x is negative on the left side of the origin. So that's these two quadrants. So as you're drawing it, now that we know the related acute is 45, you're going to draw it right down the middle of each of these quadrants and label the pi over 4 towards the x-axis. And so you have to think about how many sections are we dividing pi into. So we're rotating. This is pi right here. And we're going not a full pi. We're having basically 1 section, 2 sections, 3 sections of these quarters of pi. So this is 1, 2, 3, and 4. Another way of thinking about it, as I mentioned in a previous video, pi is 4 pi over 4. If you reduce it, it's just pi. So we have one slice less than pi and one slice more than pi. So if you're trying to quote this angle here and this angle here, you know that this would be 3 pi over 4 for this one slice less than 4 pi over 4. And then 5 pi over 4 is the one slice more than this pi, 4 pi over 4. Okay, so that's the answers. Now, in general, if you ever were requested to record general solution, you would say theta is equal to 3 pi over 4 plus full revolution is 2 pi k, and k here represents an integer. Or we have to actually quote the second version as well, because if as k's go through all the integers numbers, you will only get answers that fall on this terminal on right here, not ever in quadrant 4. So you have to quote the other one, 5 pi over 4 plus any multiple of the period. And this is the general solution. All right, let's do the next example. Here we have definition of sine is y over r. Ask yourself, is this actually a special triangle type of question? Radius is 2. So when radius is 2, we have a 30, 60, 90 type of triangle. And in that triangle, we do indeed have a root 3 as part of the sides. So then ask yourself, okay, y is negative root 3. So that's across from what angle? So you should remember 30 degrees, 60 degrees, 90 degrees. They correspond to, 30 corresponds to a size of 1 across from it, 60 size of root 3 across from it, and 90-degree angle is size 2 across from it. And with 45-degree angles, I'll just record it even though it's a little bit easier to remember, it's 1, 1, and root 2. Okay, so because we have y is root 3, we know that the related acute is the 60-degree angle, or pi over 3. So related acute, 60 or pi over 3. Important to know the radian version of this, because as soon as you see this denominator 3, your answer will have denominator of 3. We just don't know how many sections of pi we're going to include until we draw a picture. Let's draw the picture. Sign is going to be negative in quadrant 3 and quadrant 4, because it's negative on the bottom. 2, you can use cast rule, or the fact that y is negative below the origin. So this is pi over 3 here, and this is pi over 3 here. And instead of counting off sections this time, I'll just go straight to the fact that pi here could be recorded as 3 pi over 3. Use the denominator that we figured out. So 3 pi over 3. So we're going to be rotating one section more than 3 pi over 3. That gives us 4 pi as one of the numerators, 4 pi over 3. And then the next one would be almost a full revolution, which is 2 pi. 2 pi using denominator of 3 is 6 pi over 3. So we're not quite full revolution. We have one slice or section less. So one slice less would be 5 pi over 3. And so general solution, you'd have theta is equal to 4 pi over 3 plus any multiple of 2 pi, or 5 pi over 3 plus any multiple of 2 pi. Okay, a few more examples. Sine of -1. So we have -1 over 1, and this is y over r. Radius being 1, that doesn't happen on a triangle. That happens on a quadrantal angle. So we know that this is a quadrantal angle. I'm going to draw a unit circle and ask myself, where is y negative? Y coordinate negative. So as you go through each coordinate points on a quadrant, this is, 1, 0, this is 0, 1, and 0, or -1, 0, and 0, -1. So you're going to look for the y values. Where is the y value negative? And there's only one position here. You notice as you do these, you usually have two answers. In rare situations, you'll have one answer only, within one revolution, that is. And sometimes there's 3. All right, so the only theta in the first positive revolution is 3 pi over 2. And if you wanted a general solution for all the possible solutions or all the angles, that answer this question is 3 pi over 2 plus 2 pi k, where k is an integer. Sometimes integer is recorded as a capital Z in some textbooks. The next question, we have definition of cosine is x over r. So in the past, I have always said, y is across from root 3, and so that's related acute is 60. Now be careful with x's, because related acute is always across from the y, so that's why you can just look at across from it. So x is not across from related acute, so you have to just be careful with that. So just recognize if we have radius of 2 and x is root 3, y must be 1, and so across from 1 is the 30-degree angle that's related acute, or pi over 6. All right, so let's draw that. Cosine is positive in quadrant 1 and quadrant 4. And so that's pi over 6 here, and this is pi over 6. And so our theta 1 and theta 2 will have denominators of 6. And now we just need to figure out how many sections. Well, the first one is a first section, or one section of pi, so 1 pi, or just pi over 6. And the last one here is almost a full revolution, which is 2 pi. It could be recorded with denominator of 6 by writing 12 pi over 6. And so we have one section less than 12 pi over 6. So it's going to be 11 pi over 6. Okay, let's do tangent example. Tangent of root 3 over 5. This you will notice is not a special triangle type of question, so you need to use your calculator. Now, because we're looking for answers in radian measure, make sure your calculator is in radian mode. So I'm going to start off by finding the related acute angle first as rough work. If this ratio was negative, just drop the negatives. We're looking only for the related acute, which is always a positive quantity. And so we're looking for only something that's acute. Okay, so we have root 3 over 5 inside of tan inverse, and we get 0.333. So now we have to decide what is this? What does this represent? Well, this is the related acute of an angle in which quadrant? So we have to decide on the picture. Tangent is positive in quadrant number 1 and 3. And so this related acute that we just found is 0.33 towards the x-axis, between the x-axis and the terminal arm all the time. So never put it between the terminal arm and the y-axis. And so to quote this, we might want to know what each one of these representations is in decimal. So this pi is approximately 3.14. Pi over 2 is approximately 1.57. 3 pi over 2 is approximately 4.71. And 2 pi is approximately 6.28. So this 0.333, it actually makes sense to be closer to the x-axis than I have drawn it, just because if you compare it to this number, it's really small. Anyways, we need to quote the answers. So the first revolution is itself 0.333, or let me just keep 2 decimal places. So 0.33 radians. And then the second revolution, we go a straight edge, which is pi, or 3.14, plus the 0.333. So this theta 2 here is 3.47, okay? And in general, because this is a straight edge, each one of these angles are different from each other by 180 degrees. So 180 plus another 180, you keep getting back to the terminal arm. So the period of tangent is pi instead of 2 pi. So in general, you should record it's 0.33, or you can actually do that one. It doesn't matter which one you start. I'll do the small one, plus just pi k. So this is the answer for that one. All right. One more example. We have tangent is equal to -2. -2 could be recorded over 1. Both of these 2 and 1, they look like they're special triangle quantities. But if you record the definition of tangent, tangent is y over x. And 2, remember how I said 2 over 2 is always the radius, and that's not what we have here. So this is, again, not a special triangle type of question. So we're going to use rough work to find out the related acute angle by doing tan inverse of just 2. Again, drop the negatives when you do this. We're looking for just the related acute here. And so the calculator gives us 1.107. So when you're drawing this, look back to original. Tangent is negative in quadrant number 2 and 4. This time I'm going to draw it a little bit steeper because of that number. This is in between here, 1.107. Here, 1.107 as a related acute angle. And so final answer would be theta 1 would be, we're going pi, which is 3.14, subtract this 1.107. So if you do that, you'll have 2.03 roughly. And then this one, you have a full revolution, or 6.28, less by 1.107. So that would give us theta 2 close to 5.17. Okay. And then general, the theta would be 2.03 plus pi k. Now, I just want to do a quick note. If you were to work with the original ratio with a negative, meaning not dropping out the negative, I want to show what happens here. So tan inverse of negative 2 in radian mode. Let me just do that quickly here. Tan inverse of negative 2. I get, on the calculator, it's giving me a number negative 1.107. So this actually is the angle right here, but it's not in a positive rotation. It's a negative rotation angle. So you could still work with this, but I think it's less confusing if you find just the related acute and know that you have to label that always towards the x-axis between the terminal arm and the x-axis, and then there's no confusion where that is. Also, if the question dealt with, let's say, cosine, so instead of tangent, it was cosine theta is equal to, I don't know, negative 0.6. So if you were to find theta as cos inverse of this negative 0.6 and not drop the negative, I don't want you to make this mistake, so I'm going to talk about it. So cos inverse of negative 0.6, the calculator gives us 2.21. So if you weren't thinking about it, you would say, oh, okay, so we have negative cosine is in quadrant 2 and 3, and so this 2.21 is the related acute. You would be incorrect. The reason for that is, remember how I told you to label the axis as 1.57 over here, 3.14, 4.17, 6.28. So these are the approximate versions of the angles on each one of these axes. So this 2.21, that's bigger than 90 degrees. And how can that be the related acute? So this 2.21 actually is not in here. It's still in the same quadrants. Everything got erased, sorry. So it's this one right here is 2.21. And the related acute, you can do 3.14 minus this 2.21. So the related acute is the 0.93. Okay, so just be careful of that. If you are working with the negative, then the calculator may give you the actual rotation that you need. So watch these numbers in red and compare them to double check what you have is what you want. If you want to avoid this mistake, drop the negative when you do the related acute angle. Whatever you get here will always be acute, and then you can label it right into the related acute position without really thinking too much about it. Okay, I hope this was helpful.